Okay, so first a short introduction. My name is Viktor, Viktor Farcic. No, sorry, I'm in Serbia now. I'm Viktor Farcic, actually. So I work for a company called CloudBees. We are a company behind Jenkins. Any of you using Jenkins? You know what Jenkins is? That's what I like to hear. I'm also very close to Docker folks. Using Docker, anybody? Shame on you. Everybody should be using Docker. So yeah, I'm kind of member of, not kind of, I'm member of Docker Captain community that we are evangelists or something like that. I'm not employed by them though. And a couple of books, not really relevant right now. So let's get going. I will be speaking about self-healing systems today. But before I move into the subject a bit deeper, let's discuss continuous delivery or deployment. Any of you doing continuous deployment today? Every commit goes to production? Maybe one, maybe two. Okay. But that's where we are moving right now as an industry. That everything is so automated that every commit that we do to our repository goes to production, right? After a very extensive and elaborated the continuous deployment pipeline or continuous delivery, same thing. Anyways, so what we do with continuous deployment, in a general terms, it might vary from one person to another. We provision our environments, we test what we did, we build our environments, test what we did, deploy, test, do this, do that, test. The point is simply we do a bunch of stuff, and after each of the steps, we test whether actually that was successful or not. Right now, this is all thing kind of, if you're not doing continuous deployment, at least probably you're on your way there. It's no real mystery. It's been around for a long time. Now, the problem with continuous deployment is that people usually forget about what happens after that, right? You put it in production and say, hey, I'm going to my next feature, right? And maybe even leave to your IT department or operations or whatever you call them to figure out what happens next, right? But what happens next is very important. And to begin with, we always need to monitor what we're doing. You need to monitor your live system. Everybody is already doing that, hopefully, otherwise you would be out of business in a week or something like that. You need to react to problems. Now, most companies have processes that when they say that reacting to problems means that somebody is calling you at 3 o'clock in the morning saying, oh, this is down, right, fix it. And the problem why that is happening is that we as the industry, at least most of the industry, is still in a phase where we are trying to react to problems, right? First we wait until something happens, and when that something happens, then we try to fix it somehow. And those things usually tend to happen when we least expect them. Saturday night when you're drunk or something like that. But what we are trying to do now is instead of reacting to problems, we are trying to prevent problems from happening in the first place, right? And we have quite enough tools today and processes that we can really do that. We can prevent problems from happening in the first place. But more importantly, we need to move. If you want to do things fast enough, you need to move towards the direction where you're automating not only your continuous integration, delivery, deployment, whatever you're using, but also automate everything that happens afterwards, right? Like, for example, what happens when your service fails, right? You shouldn't be called 3 o'clock in the morning to fix that. There should be automation in place that makes sure that such a thing is not a disaster. We should embrace that failure, accept that it will happen, because everything fails sooner or later. Servers fail, services fail, everything fails. So we need to figure out what we do when that happens, and what we do without humans, right? What I'm trying to do at my job is usually to remove you guys from doing what you're doing, and move everything to be quite automated and proactive. So one of the biggest problems I'm facing when I talk with customers, with enterprises, for example, big companies, is that they're always trying to accomplish some kind of perfection, right? They have architects that spend months designing some documents that define some architecture that will be perfect and it will never fail, right? And then they spend hundreds of thousands of dollars into hardware that is so good that it will work forever, right? so application never failed. Then they try to design services that can accept any amount of load, right? If it's 10 users visiting our site, great. If it's a zillion users visiting, it will still work. They're trying to put processes in place that will prevent us from introducing any bugs in our code, right? Our code has such tough processes and reviews and God knows what that will actually eliminate any bugs from happening in the first place. And I already mentioned hardware. That's all false, right? All those things are completely impossible. It cannot happen. It's a myth. And the problem is that us trying to accomplish something that is impossible to accomplish prevents us actually from looking into other ways how we can do things better. Because the fact is, yeah, applications fail, services can do this and that, commits introduce bugs, all those things happen. We know that, and somehow we try to fool ourselves thinking that we can prevent that. Now, when I was starting on working with such systems, trying to prevent things from happening in the first place, my main inspiration was life, right? Kind of, if you observe how life works and how life emerged and how life evolved, we can actually learn some lessons and apply them to our systems. And one of the rules of life in general, everywhere, is the system is always more important than individuals, right? None of you as individual is as important as the system is, right? If one of us gets sick or one of us dies or something happens, as long as the system prevails, that should not be considered a bad thing. At least that's how life works. Now the next thing is that during evolution, things were always happening in very small and incremental changes, right? You never do Big Bang. You never try to change many things at once. Because if you change many things at once, then bad things happen, and you get, as a result, you get dogs called poodles, right? They should not exist. So another one, reproduction, right? Life needs to be capable of reproducing itself in order to establish certain level of equilibrium. And when I say reproducing, I don't mean only beings, creatures like humans, but also every element in our body needs to be capable of reproducing. And finally, and most important for this talk, we are all capable of self-healing, right? We are attacked by viruses, things happen to us, and somehow most of the time we don't go to doctor because we would need to spend whole life at the hospital. Simply our life recuperates from whatever is happening to us. So now, if you look at all that, you get to the conclusion or point that the most important part of our systems, bodies, is a cell, right? And cell has certain characteristics that we are trying now to apply in architecture of our code and in our systems. And one of those characteristics is that cell is capable of restoring itself into a state of equilibrium. And it does not do that by fixing itself, but by reproducing, right? When equilibrium is misplaced, cells fix that by reproducing, increasing number or decreasing depending on what you need. Now, it also needs, we are capable of monitoring our own processes, right? And adjusting. When you start running, then certain processes happen, certain chemistry in your body, and your body state changes. Your body is changing all the time depending on what is happening and what influences it reaches from outside. Finally, reproducing, I already spoke about it, and we are capable of healing precisely by the process of reproduction. So now, if we move all that biology lesson into systems that we are trying to build today, we can make some analogies, right? We always start with a data center, unless you're a very small shop that works on one server, maybe two. Otherwise, you have a data center, right? That has a certain number of servers. You can consider that the data center as a whole as let's say, a body of an individual. You have an orchestrator that is equivalent to our brain, that orchestrates everything that is happening in that cluster, right? Cluster is one unit, big unit, and then orchestrator does continuously, every minute, every second is performing certain actions to put that data center in a state of equilibrium, right? Finally, microservices, and there is a very good reason why you will probably hear many talks on microservices those 3 days. We are moving towards microservices as a preferable architectural concept, simply because they're small enough, and we can do with microservices or services things that we cannot do with huge monolithic applications. And finally, there is a reason why last couple of years the number of suddenly microservices became popular, even though they're in use for at least 15 years. And one of the reasons why microservices are popular, because they were very complicated to do before, because they produce quite a lot of technical obstacles, right? But now with the emergence of containers, many of the problems that if you tried to use microservices, let's say 10 years ago, many of the problems that you might have had at that time now disappeared. Not all problems ever disappear, but with containers, many of the things are really much easier to handle and much safer. Finally, we need a way to scale stuff. And when I say scaling, I don't mean an operator going to the data center and saying, I'm going to scale this application, right? Now I'm talking about scaling that is continuous, something that the amount of traffic increases, your service X scales up, the number of amount of traffic decreases, it goes down, right? The number of instances is in a constant change. It's very dynamic. And that's how we handle the changes that affect our systems from outside. And that's also one of the reasons why we are rarely talking anymore about designed system. What is designed is becoming irrelevant, because design is important only the first day, first moment. The moment it goes live, design goes to trash, because our systems are getting influenced by outside effects, right? So design state is something really undesirable. What we really want is some kind of equilibrium. And finally, self-healing. So no matter which, and I'm going to shortly discuss tools a bit later, but no matter which tools you use and which processes you use, every single self-healing system, or at least system that is going towards self-healing that I've seen, always have same elements, right? Unmistakably, simply because all of them are required in one form or another. You might use certain tools that you don't know that they exist, but they exist for sure, whether you set them up or they come as part of something. And but before I go into tools or process, what does such a system need to have, right? Such a system needs, first of all, you need to be able to discover the problem. If you don't know that the problem exists, you cannot fix it, right? So discovery of the problem is always the first element and always the first thing to happen in a system if it's going to be self-sufficient. Now, once you discover the problem, you need to restore yourself into state of equilibrium or desired state. Again, not a design, desired. Make decisions what to do next. Because even though you restored yourself into a certain state, there are still usually actions that needs to be performed afterwards. And adapt to change conditions. So now, once you have a very, very broad pictures of what things needs to happen, and they're more or less logical, anybody can come up with those things, you need to find out which levels of abstractions you're going to use. And you need to use both of them, right? The first one, application level healing, that's very easy, right? All of you probably did it. At least all of you who are coding did it before, because if you're a Java developer, that would be the famous try catch finally, right? To put it very simplified way, what happens when something bad happens, then we do something, right? Now, the truth is that most of the code is really bad today, and people just propagate changes up to the main method. But that's a separate question. I think that there will be, for example, these days there will be one talk, or at least one, about actors model, which are moving forward much further than, for example, simple try-catch can do, and can make your systems more resilient. But no matter what you do, you're trying to figure out through your code what happens. That's the easy part, right? Much harder part is how to design your systems on a whole system level, what should happen when something happens, right? And finally, hardware level of monitoring and reacting and preventing is becoming more or less irrelevant, because we are all slowly moving, or will be moving, to much more elastic and cloud type of hardware, where failure of something should not be a big deal. So of course, reactive is what, for example, the example of try-catch, that would be reactive healing. That would be what we predicted that will happen and what we do with it. And preventing is the subject. So let's see, prerequisites for any such system would be, first of all, and it goes in certain order, that if you do not manage to fulfill the prerequisite number 1, it's almost pointless to go to number 2, because they're all followed in certain order. So the first one is ability to deploy to any server inside a cluster that meets hardware requirements, right? What that really means is that today it's very likely that many of you are deploying to a certain server, right? You have application A, and you say, I want to deploy to servers called Mordor, Garfield, whatever you name them, right? When you start naming your servers, you're doing things wrong, because you start thinking that servers are important. They are not important at all. What really matters is a cluster, right? Servers come and disappear. And that's why, like when you give names to your servers, you're treating them like pets, right? Like when you have a doggy or a cat, right? And you make sure that it's always healthy, that it's well fed, and all those things. But where we're moving with clouds, and I mean moved already, is to treat our servers like a kettle, right? And what happens when a kettle gets sick? You kill her, right? You destroy. You simply, it's much more efficient to take down a sick specimen and make sure that it does not infect the rest of your herd than actually trying to cure, assuming that you have hundreds of thousands of cows or whatever you're having. And the same thing is happening in cloud today. When your server goes down, one of many servers here in data center, you should just destroy it, right? If the hard disk is broken, if something happening bad, just destroy it, right? Because you will bring a new one up, create a new server, and hopefully your creation of your service is fully automated. You're using something like Terraform or Ansible or whichever of those configuration management tools you're using. Now, another thing, I think that this is the part that where any of you operators are, no operators in this room. That's good, because nobody will get offended. Kind of, servers should have no SSH even. Kind of, why would you SSH into a server, right? Imagine Google size, thousands of servers. Are you going to SSH into each one of them and do something? That's just kind of, that's becoming completely inefficient. We have much better ways to handle things than SSHing into server, at least when humans are in question. And finally, you cannot effectively use a cluster. And when I say effectively, I mean cluster where servers are going up and down. Services are being deployed to one or the other, moved around, scaled up and scaled down. You cannot do that if you use configuration files, right? And if you're having a configuration file where it says the IP and the port of a database, only 3. You're the most advanced crowd I've spoke with, literally. Huh? In? Hard-coded in code. Yeah, yeah, okay. So it didn't get even to the point of having configuration files. That's excellent. Simply, you cannot hard code. Now, it doesn't matter whether it's inside of code or inside of configuration files. You cannot say this is the address of my database, because you don't know where the database is. Even if you know where the database is right now, the next moment the server might fail and it will be deployed somewhere else, right? So you need some other type of mechanism. And that mechanism today is called service discovery. And service discovery essentially means that you have a process. It monitors everything that is deployed one way or another, and gathers that information, puts it in some central place. Sorry, not central, distributed place. And from that distributed place, any other service can get information about something else. So instead of putting hard-coded values of a database or whatever you're using, a database would be deployed. It would be registered somewhere automatically, and then a service that needs the database just goes and asks, what is the IP of the database? This one. And even that method is old. And we are moving away from the service discovery now into networking type of solutions that do it even better. So once you figure out how to deploy to a cluster, and that might be much harder than it looks. But still, deploy to a cluster as a single unit, not to any individual server, then you can go to the second part. And second part is how do you deploy without downtime? And how do you automatically scale and descale instances, right? Most of you, I bet, when you deploy, you probably have some downtime, right? If you're deploying using traditional approach, you're probably stopping a running instance of something and putting a new release on top of it, right? If you're very fast, lightning fast, it might be a downtime of a millisecond, right? More likely it's seconds or minutes. Or even more likely that you're going to your office at Sunday because that's when you have least amount of traffic, and then deploying a new release, right? And that probably involves the whole team because nobody knows what will happen. Now, instead of that, we are using, again, this is, for example, one of the things that is very hard with monolithic applications. So monolithic applications try to forget about that as a concept. One of the ways you can do that is through blue-green deployment. And if you're using blue-green, do you know what blue-green is? Okay, 4. That's disappointing. Blue-green deployment in a nutshell is that you bring up new release in parallel with the old release, so they both happily live in parallel for some time. You test, make sure that it is running correctly, and once you're done, you change your proxy configuration to point to the new release, right? Very easy. Unless you're using monolithic applications, because then you're gonna go bankrupt with the amount of servers that you need to finance with blue-green. But other than that, relatively easy. Or rolling updates, which is a not so different concept, but the idea is that instead of bringing a new release in parallel with the same amount of instances, you would just, let's say you have 10 instances of your application of service, then you would upgrade one instance at a time, right? You upgrade one instance, so you have 9 instances running, then the new release comes up, and so on and so forth, right? Relatively easy with the tools that we are having today, right? It's more kind of, the bigger problem is mental model that needs to be adjusted in our heads, I think. And finally, relative scaling. And relative scaling, I think that I'm still not seeing good enough tools to do that. Relative scaling means that it's not good enough for me to say that I want 10 instances of this application, right? What we really need today is to be able to say, okay, when traffic increases by this amount of this percentage and things like that, I want to increase my number of instances by factor of 0.2, right? Or by 3 instances or something like that. So things need to be completely relative. You cannot hard code any more values because you don't know what your state of the system is at any given moment anymore. It's fluctuating, it's changing all the time. So once you figure out how you can do things without downtime, and remember, I'm now talking about something in the context of continuous deployment. I'm not talking about whomever is working in waterfall model that is deploying once every 4 months or half a year. This is completely irrelevant because you can have downtime once in half a year. I'm talking about downtime produced because you're deploying multiple times a day and multiple number of applications or services. So once we go there, we need to figure out how we monitor hardware and how we dynamically adjust server capacity, right? So it's ridiculous to say, okay, today I need 10 servers, but I'm going to buy 100 just in case, because tomorrow my traffic might increase, right? That's one of the reasons why we are going to cloud providers, because they can guarantee almost unlimited number of resources, while we are paying them only what we use at any given moment. But elasticity is critical, both on service level and on hardware level, if you want to do stuff. Now, the easiest way to accomplish that elasticity is by reacting to things like what I said before. Your traffic increases, and you bring up a new server with your services and whatever needs to be there, right? Now, that's an easy part, but it's very devastating. It has a very devastating effect on our business. Because if you react, it means that some users are already experiencing difficulties, and then you fix those difficulties by doing something, but difficulties were there, bad experience was there. So what we're trying to do is prevent, meaning that you need to store everything that is happening on your servers continuously, and not only monitor the state of your cluster in real time, which I mean, first step is real time, of course, but that's easy. But what you need to do is go back in time and try to figure out, based on data from past, figure out what's going to happen in the future, right? You can start with easy stuff like, what was happening an hour ago? What was happening in my cluster yesterday, right? And depending on what was happening yesterday, at the same time, we can predict probably what will happen next. What was happening the same day last year, having in account all those combinations, right? We're closing towards machine learning, but long before you get there, with the simple scripts and a bit of intelligence, you can accomplish a lot, as long as you have all the data that you need, right? And at the same time, don't exaggerate with the amount of data, because then you will have too much things to manage. Finally, so we are monitoring services in near real time and execute reactive actions. One of those monitoring methods are service checks, right? You can ping your service, are you alive? If you're not alive, I'm gonna do something, I'm gonna bring a new instance or something like that. Then once we know that something goes wrong, we redeploy our application and live happily ever after. And finally, actually, I spoke about it already. I did things out of slides. So yeah, predict the future and do proactive actions. What most of you are probably doing is some scheduled scaling. You know that around New Year's Eve time you will have increased business, and so you put in Jenkins kind of like 31st of December, scale up to 5 instances more, right? But that's using our collective memory, our collective experience to try to predict the future, which is usually not enough. Then on historical options, that's what I spoke before about using historical data to try to figure out what will happen next, and so on and so forth. So tools. No matter which ones you pick, you will always need these types. You will need a cluster orchestrator. You need something that will make sure the cluster is always in a desired state. Some real-time registry. Some historical registry. Some monitoring tool. And some general orchestrator. Always, no exception. Now, for cluster orchestrator tools, almost everything interesting happening in this area today is somehow related with containers. Even though many people choose Mesos because they think that it works without containers, because they think that only Docker is containers, is nothing else. But anyway, 3 major players today are Mesos with all the ecosystem it has around it. Kubernetes. Any of you using any of those? Kubernetes Swarm? You said you use containers. You must be lying if you don't know what this is. Okay, so all of them, basically, in a nutshell, what all of them do is you tell them desired state of something. You tell Swarm, for example, I want 5 instances of this service, and Swarm will monitor your cluster all the time and make sure that 5 instances are running. If a server goes down, it will reschedule those instances somewhere else. It will change the networking. It should do a lot of stuff that you need not to worry about. I mean, you should worry about, but they do it for you. So, but yeah, I won't go into discussion. We can speak afterwards the difference between those tools. But they all, if you haven't used any of them, any of them would be good enough for you, I guess. So once you figure out what's going to be your cluster orchestrator, and hopefully one of those 3. No, actually, hopefully Kubernetes or Swarm. Don't use Mesos. you need some kind of real-time registry, right? And real-time registries needs to have certain properties. First of all, they need to be prone to failure, meaning that you need to have multiple instances of any of those running inside of your cluster, so that if one goes down, the rest will pick up. And having multiple instances means that data needs to be replicated among all of them, needs to be lightweight, and many other things. They all use the same idea behind. They all use no, actually not all. Zookeeper no, but the rest of the two use gossip protocol to propagate information across all the instances. Very easy. No, very hard to do, but very easy when you use those tools. Now, Apache Zookeeper started eons ago. It's probably one of the first tools widely adopted. Not a good choice anymore. Still use these Mesos though, but if you wanted something like that, just go with etcd or Consul. Both of them are exceptionally good. Now, once you figure out where to put your data, and I'm talking about real-time data, then you need to figure out where to put your historical data. Those, the previous set of tools, they're not designed to host terabytes of data. They're designed to just have the information about the current state of the system. Elasticsearch, on the other hand, and there are many other tools, many online services that you can use, or offline, on-premise, whatever you want. I mean, they're popping like mushrooms after rain. The reason why I'm saying now Elastic more than anything else is simply because I personally have more experience with Elasticsearch, but any of those will do quite good. And Elasticsearch is probably very it has many other usages beside this, but in this case, I'm just interested into historical data, right, about your system. Finally, monitoring. If you use any of those two, go home. They are very old. They're not designed with such a dynamism. I'm sorry if I offended. They're not designed to take into account such a dynamism as we're expecting from the system today. They're designed to monitor things in a very static way, right? They're designed to do things in a monolithic ambient where things are not rescheduled, things are not redeployed, scaled, and so on and so forth. Very static, very bad. It was very good back then, but not now anymore. What is much better, for example, is if you combine Elasticsearch and Kibana, you get a very dynamic, a very good combination. You can use Consul for monitoring. You can use the new kid, Prometheus. If you are really patient and you want to dedicate enough time to learn it, Prometheus is probably the best choice. It's very close to what Google uses, even though it's not the same to monitor their systems and perform certain actions. So really recommend. Finally, Jenkins. There are many other tools. It's not really that important whether you use this or that, because once you figure out everything else until then, all of those things that we spoke about, putting it all together, you can do it even with the cron tab, right? Even cron tab can fulfill your general orchestration once you figure out everything else, right? Because all it has to do is just execute some actions that you require from it. So I don't know how I'm without time. Yeah, it's actually, we have, buy my books, that's commercial. So I always try to end up talks relatively much faster than the time I have, so I don't like speaking in one direction, so if you have any questions, that would be really great. First one who asks the question gets free Jenkins for free. Doesn't work? Okay. Okay, questions. You're a tough crowd.
Oh, I'm sorry.
Sorry, can you tell why not Mesos?
People complain when I answer questions that are not politically correct, so I might be offending. Mesos was never designed to run. If you use containers, chances are that you're going to use Docker, right? Maybe Rocket, but more likely Docker, right? And Mesos was never designed to run containers, at least Docker, right? It was something that was added later. It's, if I would need to describe it, it would be like, if you take my grandma and put a lipstick thinking that actually it will suddenly become young again, It's very slow. It's based on Java. I have nothing against Java. Actually, I do, but not in this context. It's relatively resource demanding, relatively slow, and so on and so forth. Now, it's a similar situation like Zookeeper. It's a great product. It's a great tool, and it has a really great community. It's just that the later ones that are coming, like Swarm and Kubernetes, are avoiding some of the pitfalls of Mesos simply by starting later, right? The same way as many problems in Java are fixed with Go, not because people who design Java are stupid, but because it was designed in some different era. But if you use none of them, any of them is amazing. It's kind of like you will think that you're in a Disneyland or something like that, magic happening all around. Anybody else? Yes, oh, there's 3 questions, excellent. I don't know who, do we passing microphone or something like that? She's coming, look at her, running, excellent.
So, question about blue-green deployment and maybe
Yes.
your red-black deployment.
Yeah.
Can you elaborate the difference?
Huh?
Because you didn't mention the other ones.
I don't have, I mean, I know in theory, but the other ones I haven't used myself in a practical way, so that's why I'm not, I try to avoid, you know, bullshitting with the stuff that I haven't done myself. But in essence, they're not really that different, all based. Even blue-green and rolling updates are not essentially much different. It's just that things are happening on instance level instead of service level. I didn't give you a good answer, but that's how it is. Yeah, whomever.
Hi. One thing about the blue-green deployment. So one of the problems are data migrations usually. So you either have to support both data schema models in the blue and then do the migration, or you have to do some kind of magic. Do you have any solution for that problem?
How long is your iteration first?
A week.
A week, okay,
Yeah.
okay. So then I mean, I thought if you tell me months, then we are in deep trouble. You try to make database changes backwards compatible always. And that's not only because of blue-green deployment, but let's say even if you don't do blue-green deployment, let's say Big Bang type of deployment, whatever you do, right? Still, your database changes always needs to be backwards compatible because let's say something goes wrong. You want to roll back your service, your application, whatever you want to do. You cannot roll back database. It's impossible to roll back database once it starts accumulating transactions, right? So your database changes always needs to be backwards compatible, no matter which deployment method you use. And now if it's backwards compatible, then blue-green is relatively no-brainer, simply because your release 1 and release 2 are both capable of working with release 2 of your schema, right? That means that, let's say, in a very simplified way, and I know that things tend to get much more complicated in real life, but if you're planning, if database change is supposed to remove a column, just don't do it now, do it later, right? Adding a column is not a problem, and also so on and so forth. That also means that your code needs to be capable of speaking with both releases of a database. If you're using NoSQL, then things tend to be easier. If you're using relational databases, then they're a bit more complex. But as long as, now there are always situations that you cannot do it. It happens every once in a while, but in most cases, it's more like kind of getting used to a different way of thinking, a different way of working, assuming that your iterations are relatively small, right? If you're changing small thing in a database, making the backwards compatible is not a big deal. Now, if we make, I don't know, I'm going to change everything into something else, then your processes are wrong, not technology anymore, I think.
How applicable is the dynamic scaling when you're not using the cloud? So when you have the fixed amount of servers and you can't treat them as cattle?
But when you say fixed amount of server, do you have spare capacity?
Well, you have some spare capacity, but not enough so you could raise a factor of more services.
Then it becomes more complicated because if you want to scale your service into existing hardware that is already on full capacity, you have a real problem. On the other hand, in most cases, if you adopt cluster way of thinking, even without elasticity, if you adopt Kubernetes Mesoswarm, something like that, then actually your resource usage is almost certainly going to drop. You'll use less resources for a simple reason, because if you deploy statically, application A goes to server B, then there are always wasted resources, right? We are never capable as humans as deploying and using maximum. Those tools cannot either use maximum, but they can get closer to maximum resource usage, and you might have a more leverage there to move around. But sooner or later, if your business is going well, right, and I hope it is, then you will need to scale up and up and up and up and up. More users, more traffic, more this and more that. You need to be. Now, more and more companies, especially those traditional enterprise companies, they're adopting a hybrid model. Kind of, oh, I'm scared, Amazon is unsecure, which is complete nonsense, right, that Amazon is insecure. But okay, let's assume for a moment that it is, but then they're adopting hybrid model, meaning that we're gonna have our in-house cluster that has limited fixed capacity, but we're gonna use cloud only when the access appear, right? So when you need a temporary boost in something, you add cloud instances just to fix your problem, right?
I have a question which is slightly off topic, but
Sure.
just slightly. Because I've been fascinated with the things we know with automatic monitoring, with automatic upscaling, with automatic downscaling. What are the business implications, basically, when it comes to paying those server costs? Would it be viable to think that if you have basically an instance that monitors everything and tries to scale up automatically, and you have a competitor that just wants to drive your costs up, he would like do some sort of DOS or DDoS on your servers and slowly be bleeding money out of your budget for servers? Because if there is no human to monitor the activity, basically the traffic, if you just leave it there hanging,
Sure.
you're digging your own grave.
That's correct. I mean, if, for example, you have DDoS and you have just a script that scales up when an increase in traffic, you're doomed. So you almost, if you're doing things right, you always have caps or limits, right? You say, I assume that up 10 instances is my optimum, right? And I allow you to scale up to 50%, right? You never allow unlimited scaling. In the same way as that you never allowed unlimited downscaling, right? Oh, my services are responding lightning fast. I don't need so many of them. I have one. I'm going to go to 0, right? You don't do unlimited in either direction. You usually try to limit in percentage, usually lower and upper limit of number of your instances, right? And when I say that self-healing, it's almost the same thing like with us. It's never 100% self-healing. Our bodies self-heal in most cases, but we still occasionally go to the doctor. Same thing with the system. So I'm not saying that we can remove fully humans from the process, but we want to limit humans to things that are exceptional, right? Not from doing repetitive mundane tasks over and over and over again. Google, for example, is very advanced on those things. They still have quite a big amount of, they call them SRE engineers that act when something happens. But they try to prevent, just to prevent as much as they can. But to your short answer, yeah, you have limits to how much you go up and down. And also, you mentioned your competitor was to increase your costs, which is true. With limits, you can fix that. But once you do adopt dynamic scaling up and down, then actually your costs are going to drop almost certainly. Because usually we design system saying, this is my maximum expected capacity. So you always kind of run system in a maximum capacity. If you dynamically go up and down, then you can, during the night, number of instances of A goes down, so that frees resources for something else to happen, batch processes and things like that. Did they answer? Thank you. Anybody else? I don't know, how much time do we have, folks? We have time, right? Questions? Yes.
Thanks a lot for the talk. Quick question. You talked about scaling up and scaling down, and that there are some services that take care of the time, the point in time that you need to scale up, for example. Do you have, from your experience, a good some metrics that you could take into account when scaling up? For example, it's just CPU, memory, just network requests, or?
I mean, it's usually starts. Basics are more or less those that you mentioned, right? I mean, actually, the amount of metrics is relatively easy to declare because metrics is your hardware, meaning CPU, memory, hard disk, this and that, and network traffic. Those are the most important. It's not that much what we record. It's more what we do with those data. And that gets complex because, as I said before, for example, network traffic in itself, real time, is not that important. I mean, it is important, but it's only first step because if you say, oh, at this moment I have increased traffic, I'm going to scale up, you're probably going to do some very bad job because that might be a temporary boost in traffic that is going to 5 seconds later go down. So you need to take in account longer period of time and start with time doing more and more complicated calculations. But the data is relatively, it's unlimited in amount, but the types of data is relatively simple. It's more or less those.
Hi. Actually, about this topic itself. So I've had to go through the pain of actually implementing an in-house auto-scaling mechanism for AWS, just because I could not find anything that could do the job, basically because your metrics are quite intimate, right? It's how your application works. Have you ever encountered some solution that even gets close or is trying to get there, sort of an elastic solution that can really work for auto-scaling at scale?
And when you say scaling in AWS, are you talking about scaling VMs or are you talking about scaling
It's about scaling
service?
the cluster, yeah, within the cloud, so scaling actual instances for the
of
application.
services, yeah. I mean, if you're asking about the, I mean, in number of features that are offered, Kubernetes goes further than anybody else. Maybe Kubernetes and Mesos, that are kind of shoulder in number of features. So they're really powerful. Kubernetes especially is a bit intimidating because it's too powerful for my taste. Because Kubernetes was designed from the first day, kind of like everybody's going to run Google size of stuff, right? We all the complex stuff, but Kubernetes is a solution. I mean, others are a solution as well. But if you want the biggest number of features to allow you stuff, that's Kubernetes.
Yeah, the thing is, everyone I've spoken to has had to come up with their own solution at the end to have something that really works.
Depends what you mean by your own solution. Almost all solutions can be extended. So I'm not in favor of. I like in most cases places where people I work with, companies I work with, we always end up with our own solution. But I always try to guide people towards creating their own solution on top of the existing solution because whatever you're doing, chances are that 90%, I'm just throwing the figure, is already solved by, for example, Kubernetes Swarm Mesos, right? So starting from scratch with your own solution would be a bit of a waste. And all of them can be extended. For example, you can easily write a plugin for Kubernetes that implements your own scheduling traffic algorithm for certain cases, right? So I would recommend, yeah, go with your own solution. But first make sure that actually you really explored what is there and then start building on top of it. And hopefully contribute it back to the community, please. Anybody else? One. Hi.
Can you touch a bit on security in a container environment? I don't think you mentioned anything about that.
In a container environment, I think that container environments are more secure for a simple reason, because if you do it well, your solution is becoming more and more minimalistic. So where we are moving now, I think that at least those adopting containers are not going to run in the near future Red Hat or Ubuntu, simply because they are too big of OSSs, have too many things that I don't need. I need only Docker engine and maybe a few more things. So just by removing most of the things that you already have, you're increasing your security, because the bigger the distribution, bigger security implications. Now, and also the same thing is about containers. We're not using, containers are not built from Debian images, for example. They're built usually from Alpine image that is very lightweight and almost nothing inside. Now, many companies I speak with complain also security between containers, right? Oh, you know, what if team A in charge of service A wants to actually do some harm to service B, right? But to me, that's not a technological problem. That's a problem that organization has. I mean, what kind of teams do you work with if they actually want to destroy each other, right? To me, that's a human problem, not really related to the technology. But other than that, I don't see really security, because your system is still going to have close all the ports except 80 and 443. You're going to have the same thing. You just superficie of your potential attack is going to become smaller even.
So one more thing. You mentioned attacks, let's say, between containers. And you mentioned what happens if two teams try to compete with each other. And I'm more concerned about what happens if somebody breaks into a container by, I don't know, SQL inject and gets access to the system. Do you have any knowledge of these kind of situations happening?
I mean, yes, if somebody, that depends more on how your applications or services are designed in containers. At least that's how I come from. Because yeah, I mean, if somebody breaks into your system, let's say even worst case scenario, somebody breaks into your server, you're doomed, right? Now, if you don't put isolation, you're even in worst case scenario. Now, in a way, I think that microservices help with that, simply because, again, everything is split into smaller pieces. So even if somebody breaks into a database, it does not break into a Uber database that holds everything. It breaks into one of many databases, assuming that each service has its own database. So again, things are more split and more divided, and makes it harder. Not impossible, of course, but I think still it can become only harder, not easier. Now you have process isolation, but on the other hand, if you give root access to your file system and expose some volume on a host, then actually they can enter to there somewhere else. Now we can have a separate discussion that we shouldn't expose volumes in the first place, because they're just something from the past that we're not getting used to, and so on and so forth.